y equals 2 to the x plus 2 minus 1. So we have another exponential function, same sort of graph as in part A. Doesn't matter that a base is the same or different from another, we're just going to have the same basic shape. So first, we wanted to find out the location of the horizontal asymptote. So we have a shift that moves everything down 1 unit, which means the asymptote is going to also shift down 1 unit. So the vertical asymptote would be right through here, which is a horizontal line, and a horizontal line always has the form of y equals whatever the location of that horizontal line is on the y-axis. So it's at -1. So that's our equation of horizontal asymptote. And effectively, for any exponential function, it's always going to be y equals whatever that constant is on the outside, because the asymptote is going to get shifted up or down that same number of units. Next, we will graph the function. So that's part 2. So for part 2, we want to graph it. The other thing that we need to take into consideration here is that there's also going to be a horizontal shift. So this plus 2 on the inside of our exponent, that is a horizontal shift, and it moves in the opposite direction of the sign. So in this case, it's going to move toward the negative direction. So we're going to go to the left by 2 units. So what happens is, normally we have this point that's 1 unit above the asymptote that lies on the y-axis. But since everything's getting shifted to the left by 2 units, we need to take that point and move it to the left 2 units as well. So this point right here is going to be part of our graph. And really make sure you highlight that point so that your instructor knows that you've done the shift properly. Lastly, all we need to do is just draw in the shape of an exponential graph, and we know what the shape looks like. Of course, the base of the exponential does affect the shape, but we're not really interested in that. We're just interested in this direction. We go toward the asymptote, and then after this point it grows very rapidly, so just make it look basically like that, and your instructor will be happy with that. That's a great graph. Lastly, we need domain and range. So to get domain and range, one thing to note is exponential functions, like polynomial functions, are defined everywhere. So your domain for an exponential function is always going to be -infinity to +infinity. The range is restricted, however. So the range is only defined above the horizontal asymptote in this case. So we start from the horizontal asymptote, but we don't include it because the exponential graph never actually reaches that asymptote, it just approaches it, and then going off to +infinity.